Hello everyone, my name is Reem Ala. I'm 17 years old. I'm a senior studying in Dubai National School, Al branch. I'm presenting today a calculus topic about analysis of function, whether they are decreasing or increasing at a certain area, or concave up or concave down at a certain area. First, let's take a look at this picture. What if I told you that we can just look at the original function and determine whether it's increasing or decreasing on a certain area by taking its derivative? So today I'm going to show you how we do that. If the derivative of a function is positive, that means in that moment right there, the original function f of x is going to be increasing. So that means if I were to have a positive derivative at this case, it's going to be this one right there. If the derivative is negative, that means I have a decreasing function, so it will look like this, going down. If I take the derivative and I have a 0, what's happening then? Is it decreasing or increasing? Well, neither, because it's constant. It will look like a horizontal line in the graph. The steps into finding whether a function is increasing or decreasing at an interval. We have step 1. It is that you're going to take the derivative of that function. Next is step 2. As you find the zeros, that means like you set the equation equal to 0. And usually you do some type of factoring and you find out the x values that make your function equal to 0. And then you're going to substitute a number within the interval, which means you're going to figure out a number that's not a critical point by doing a timeline and plug it into the derivative and see if you get a positive or negative, and that will determine if you have increasing or decreasing once you know which interval are positive or negative. Because as we said, you can use that to figure out whether your function f of x is exactly increasing or decreasing. A critical number of a function f is a number in the domain of f where the derivative of x can be 0, or if the derivative of x do not exist. It can be shown by the graph by horizontal tangent lines or vertical tangent lines or sharp corners as well. So for this one, we are to find the intervals where the following function is increasing or decreasing. So first, let's find the derivative. The derivative of f of x is going to be equal to 3x to the power of 2, where you drop down the 3 and minus 1 from the power, so 2. We drop down the 2 as well and multiply by negative 6, so negative 12x. After I take the derivative, it's my job to find the zeros, which are the critical numbers. So we equal the function to 0. Now the way to find the zeros is by factoring. So let's factor. We are going to factor out the 3. I'm also able to take out the x. So 3x comes out. After we take that out, we are left with 1x. We are going to take out 3x out of negative 12, so negative 4. So now we find out the zeros by setting each one equal to 0. We divide the zeros here are equal to, the zeros here are x equal to 0 and 4. So I have two critical points. What I have to do now is I have to figure out the intervals in which this is increasing or decreasing. We do a timeline. Obviously there are increasing and decreasing points. We take any number smaller than 0, so maybe negative 1, and we plug it into the derivative function. So replace x with negative 1, so 3 multiplied by negative 1 to the power of 2 minus 12 multiplied by negative 1 as well. It will be equal to 9, which is a positive value. It is a positive value, so it is increasing. So we know for sure it is increasing from negative infinity to 0. We do the same for the rest, and the answer will be that f is increasing on 4 to infinity as well, because we do the same steps, we plug it in, we find it positive. And decreasing on 0 to 4, we do the same steps, we plug it in, and the answer will be negative something, so it is decreasing for sure. So f is increasing from negative infinity to 0 and 4 to infinity. Because the values are positive, on the other hand, it is decreasing from 0 to 4. I talked today about analysis of function increase and decrease. I hope you learned a lot and thank you all for listening.